Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. In our last lesson, we looked at different exponent properties. Today, we're going to talk about negative exponents. So when we see a negative exponent, we're going to figure out, what can I do with that? How can I make that positive? Before we jump in there, though, let's do a couple of problems reviewing those rules from our previous video. So I encourage you to pause the video, see if you can simplify these three exponential expressions that I have here on the page. Okay, so this first one is our product rule. Remember, we need to have the same bases when we multiply, which we do here. I'm going to multiply the numbers first, so 4 times 2 gives me 8, and then I'm going to add the exponents, right? When I multiply two terms that have the same base, I add the exponents, so 8y to the power of 6. Our second one is a mix of a power of a product to a power of a power. Remember, we need to distribute this 2 power to all three factors inside. So I'm going to get 2 squared times x cubed squared times y squared to the power of 2 as well. This will give me 4. This is our power to a power. When I have a term with an exponent being raised to another exponent, I multiply the exponents together. So I'm going to get x to the power of 6. And then with my y's, I'm going to get y to the power of 4. For our last one, I'd encourage you to do this one in pieces. So I'd encourage you to simplify the numerator first, and there's actually 2 things we can do in the numerator. One, I know that n to the power of 0 should just be equal to 1. So this gives me 4 times 1 times n squared all over 2n. So I get 4n squared over 2n. Now I can break this up. I can do the numbers separately and the variables separately. So for the numbers, 4 divided by 2 gives me 2. For my variables, n squared divided by n, well, I am subtracting the exponents here, so that's going to give me 2n. So final answer, 2n. Okay, let's go ahead and talk about negative exponents. So to simplify an expression with a negative exponent, you are going to rewrite the expression with the reciprocal of the base and a positive exponent. So let's take a look at the 3 examples here. First one, if I have x to the power of negative 2, well, I'm going to take the reciprocal of x, which is 1 over x, and make that exponent positive. So I'm going to get 1 over x squared. If this is confusing, this little, I don't know what you would call it right here, but it's a comma. I know it was called a comma. I just didn't know a piece of punctuation. There we go. So you get 1 over x squared. I guess I'll get rid of this comma as well. Here, in our second one, we have to be a little careful because this negative 3 exponent is only being applied to the m, right? So we're not going to move the 3 at all. The 3 is going to stay in the numerator. It's the m that's going to move to the denominator when we take the reciprocal of m. So 3 times 1 over m cubed gives us 3 over m cubed. For our last one, this time our exponent's already in the denominator. So if I do the reciprocal of 1 over x, right, reciprocal of 1 over x, well, that reciprocal is x over 1. So my x pops up to the numerator here, and then I make the exponent positive. A couple things to think about. One is that you can think about taking the reciprocal, or you can just think of, I think an easier way to think about it is am I going to move it to the numerator or move it to the denominator? Right? If our exponent is negative, let's just look at this last one. Our exponent's negative, but our variable, or it could be a number as well, that's in the denominator. So to make my exponent positive, I need to move the base to the numerator, and then I can make the exponent positive. It's going to be the opposite, right, when it starts off in the numerator. So if I look at this second example, right, my 3 already has a positive exponent. The exponent on the 3 is 1. So my 3 is going to stay right where it's at. It's the m that has to move to the denominator if I want to make that exponent positive. So the way I think about it, if the exponent's negative, you just need to move it to either the numerator or the denominator. Depending on where it starts, you're going to move it to the opposite. My other suggestion is that I would wait until the very end of the problem to convert your negative exponents to positive ones. If you have other rules you need to apply, I would do those rules first, and then at the very end, you can change your negative exponents to positive ones. I tend to see that that's a little easier, and students are less likely to make mistakes doing it that way. But you could convert them all to positive exponents at the beginning if you wanted to, and then apply your rules. It's up to you. Let's look at a couple of examples here. So let's look at, we'll just do number 1 for now. So like I said, there's a couple different things going on here, right? We're going to have to apply the product rule as well as think about how to change our negative exponent to a positive one. But as I mentioned above, I think we should apply the rule first and then change the negative exponent. I could change the negative exponent to a positive one and then apply the product rule. But again, I think you would see it's going to be probably more steps. So if I apply this product rule, I'm going to multiply the 4's together to get 16. I'm going to add the exponents. Remember, this exponent on the b is 1. So 1 plus negative 3 gives me negative 2. So now, because I've done all the simplifying, I'm just going to change this to an expression with positive exponents. So let's just put everything over 1. Let's make it a fraction, because I think that'll be helpful. Now we need to think, okay, does the 16 stay or does it go to the denominator? Well, the exponent on the 16 is just 1, right? So it's positive, it's going to stay where it's at. The b, though, the b has to jump to the denominator because the exponent is negative. So if I move it to the denominator and I make the exponent positive, there's my answer, 16 divided by b squared. This is what I think is the easiest way. I'm not going to show you the other way that you could do it, and then you can decide, which way is easier. So I'm going to convert this negative exponent to a positive one first. So I'm going to put everything over 1. This first 4b stays, right, because both of those have positive exponents. This other 4 actually stays in the numerator as well, right, because that also has a positive exponent of 1. It is just the b, the second b, that's being moved, because that exponent's negative, so it'll be b cubed. So we've changed it to a positive. Now we are going to simplify. You'll notice now we have a quotient to simplify. But the first thing we can do is simplify the numerator. So I get 16b over b cubed. If I think about my quotient rule, the 16 is going to stay because there's no other number to divide 16 by. And then the exponent on this b is 1, and I need to subtract. So I need to subtract 1 minus 3, which gives me negative 2. Now I have another negative exponent to deal with. So let's put this over 1. The 16 stays in the numerator because that has a positive exponent. The b, though, has to jump down to the denominator because it has a negative exponent. So jump down to the denominator, make the exponent positive. So you'll notice we got the same thing, but we added in some extra steps. And this can tend to happen if you worry about the negative exponents at the beginning. So I would just perform all of your rules. They work the same whether the exponents are positive or negative. And then at the very end, just change your negative exponents to positive ones. All right, let's do a couple more. Let's look at number 4. Okay, so number 4 has a couple different variables, and we are going to be using the product rule. So the u cubed, right, there's no other u's for me to multiply that u cubed by. So that's just going to stay as u cubed. Now I'm going to multiply the v to the power of -2 and the v to the power of -2. Well, I'm going to add the exponents, so -2 plus -2 gives me -4. I have no more multiplying to do, etc., so I'm ready to just make my negative exponents positive. Let me put this all over 1. Again, I think making it a fraction to start makes it easy to determine, where do I move each term. Well, the u cubed, that exponent's positive, so it's going to stay in our numerator. The v, though, the v term, that has to jump. That's got to jump down to our denominator because the exponent there was negative, so we jump down and make the exponent positive. So u cubed divided by v to the power of 4. Let's take a look at another one. Ooh, number 5. Okay. Couple different ways we could do number 5. We could first simplify the negative exponents. I don't think that's the easiest way to do it, so I'm going to apply my exponent rules first. Well, I'm going to apply the power of -2 to both of these factors. So that's going to give me 4 to the power of -2 times r, and remember, when we have a power to a power, I multiply the exponents. So -2 times -3 gives me +6. Well, let's put that over 1. Now we need to decide what I'm moving. Well, the 4 to the power of -2, that's got to move to our denominator, right? So I'm going to move that down, make the exponent positive. My r to the power of 6, that can stay right where it's at in the numerator because the exponent's positive to begin with. One more thing to do is just to simplify 4 squared, which gives me 16. So our final answer here, r to the power of 6 divided by 16. Let's squeeze in one more. Let's look for a little bit more of a complicated one. Let's do number 11. That looks complicated. Okay, again, I'm just going to apply the quotient rule first. Okay, so, and here, remember, I got to compare variables that are the same. So let's look at my y's. This exponent right here is 1. When I am doing the quotient rule, I subtract the exponent. So 1 minus 3 gives me -2. If I then look at my x terms, I'm going to have x and then -1 minus -4. That's going to be -1 plus 4, which is +3. So I actually get x cubed right here. So now let's figure out, what do I need to move? Well, my x cubed can stay right where it's at, right? Because that's exponent's positive. It's the y to the power of -2 that needs to move to my denominator. So move the y to my denominator, make the exponent positive. So I get x cubed all over y squared. Okay, a couple of other problems that you can practice. Again, we're practicing the rules we learned from last lesson, and now we're just having to also change negative exponents to positive ones at the very end of our problem. Again, I say at the end because I think that's the easiest place to do it. If you try to do it in the middle of your problem, you could just create extra steps for yourself. So perform the exponent rules like normal, and then at the very end, worry about changing negative exponents to positive ones. All right, that's going to do it for this video. As always, enjoy the rest of your day, and we will see you next time.